High-performance multi-channel power line monitoring with simultaneous sampling ADCs. Introduction: the rapid expansion of the electric power industry had created a worldwide need to reinforce existing transmission and distribution networks and to construct new substations. Advances in microprocessor technology and the increasing cost of support staff are key drivers for power campaigns to design new automated high-voltage substations using high-accuracy integrated automation systems. Substations can be classified in two categories according to voltage level. High voltage include 500 kV and terminal substations 110 kV. Systems architecture: each power phase is represented by a current transformer (CT) and a voltage transformer (VT). The complete system comprises three such pairs. The average power in the system at any instant is calculated by rapidly taking a number of samples of the output of each transformer.
The power line monitoring product module provided by DigiKey and Analog Devices introduces hardware and signal chain elements of power line monitoring (PLM). Learn about the needs of electric utility companies and about how power line monitoring is used for protection and to ensure quality. Examine a typical PLM system's underlying principles of operation and the necessary components required for proper management. Finally, view a discussion about the PLM market voltage segments, customer requirements, and sample signal chains for the PLM applications. Please visit www.digikey.com/PTM.
The ADC takes the two sets of simultaneous sampled 3 CT and 3 PT output and stores the results in random access memories.
The ADCs research UR210 quad radio is a high-performance 4-channel receiver which can be used to build scalable phased array systems. UR210 contains 4 channels that can tune from 700 MHz to 4 GHz. Each channel contains a pre-select filter bank, direct conversion mixer, and 120 megasample per second ADC. All channels share a common Yigtune local oscillator and internal self-calibration source. This hardware configuration provides superior dynamic range, selectivity, and channel-to-channel alignment.
System requirement: a substation might contain hundreds of transformers. The measured voltage and currents are scaled such that the plus or minus 5 volts or 10 volts full-scale output range of the transformers represents a range the power output capability of the power line. Generally, the power line, especially the current measurements, will run at less than 5% of this range, and typical transformer outputs will lie in a 20 mV range. Beyond the ADC, a complete power line measurement system is shown in Figure 4, while the ADC is the heart of the system. Many other factors must be considered when designing a high-performance system. ADC reference consideration: whether to use the ADCs built in reference for devices that have an internal reference or an external reference depends on the system requirements. When multiple ADCs are used on a single board, an external reference works best, as a common reference can eliminate part-to-part reference variations. Thus, taking advantage of radiometric behavior. Amplifier choice. The key requirements to consider when choosing an amplifier for power line monitoring applications are low noise and low offset. The noise generated by the driver amplifier must be kept as low as possible to preserve the S&R and transition noise performance of the ADC. ADC power supply generation. Both analog and digital power supplies are required for ADCs. Most systems have a 5-volt digital supply, but many do not have analog supply. Conclusion. Increasing worldwide power demands are driving an increase in the number of power lines and power line substations, as more and more automated monitoring and fault detection systems are required. The trend will be towards systems with a large number of channels, with multiple ADCs on each board. Efficient use of board area and power dissipation become critical as system designers try to reduce costs while increasing performance.